recharged one's en route. If rented, then maintenance costs can be deferred to the agency. Some BEVs can become hybrid vehicles depending on the trailer and car types of energy and powertrain. Trailers. Auxiliary battery capacity carried in trailers can increase the overall vehicle range, but also increases the loss of power arising from aerodynamic drag, increases weight transfer effects and reduces traction capacity. Swapping and removing. An alternative to recharging is to exchange drained or nearly drained batteries, or battery range extender modules, with fully charged batteries. This is called battery swapping and is done in exchange stations. 100. Features of swap stations include SAD Smiley 101. The consumer is no longer concerned with battery capital cost, life cycle, technology maintenance, or warranty issues. Swapping is far faster than charging. Battery swap equipment built by the firm Better Place has demonstrated automated swaps in less than 60 seconds. Winking SAD Smiley 102. Swap stations increase the feasibility of distributed energy storage via the electric grid. Concerns about swap stations include potential for fraud. Battery quality can only be measured over a full discharge cycle. Battery lifetime can only be measured over repeated discharge cycles. Those in the swap transaction cannot know if they are getting a worn or reduced effectiveness battery. Battery quality grades slowly over time, so worn batteries will be gradually forced into the system. Manufacturers' unwillingness to standardize battery access /implementation details. 103. Safety concerns. 103. Refilling. Zinc bromine flow batteries can be refilled using a liquid, instead of recharged by connectors, saving time vehicle to grid. Smart grid allows BEVs to provide power to the grid at any time, especially during peak load periods, when the selling price of electricity can be very high. Vehicles can then be recharged during off-peak hours at cheaper rates, which helps absorb excess nighttime generation. The vehicles serve as a distributed battery storage system to buffer power during blackouts, as backup power sources. Safety. The safety issues of battery electric vehicles are largely dealt with by the international standard ISO 6469. This standard is divided into 3 parts: on-board electrical energy storage, i.e. the battery, functional safety means and protection against failures, protection of persons against electrical hazards. Firefighters and rescue personnel receive special training to deal with the higher voltages and chemicals encountered in electric and hybrid electric vehicle accidents. While BEV accidents may present unusual problems, such as fires and fumes resulting from rapid battery discharge, many experts agree that BE batteries are safe in commercially available vehicles and in rear-end collisions, and are safer than gasoline-propelled cars with rear gasoline tanks. 104. Usually, battery performance testing includes the determination of state of charge, SOC, state of health, SOH, energy efficiency. Performance testing simulates the drive cycles for the drivetrains of battery electric vehicles, BEV, hybrid electric vehicles, HEV, and plug-in hybrid electric vehicles, PHEV, as per the required specifications of car manufacturers, OEMs. During these drive cycles, controlled cooling of the battery can be performed, simulating the thermal conditions in the car. In addition, climatic chambers control environmental conditions during testing and allow simulation of full automotive temperature range and climatic conditions. Patents may be used to suppress development or deployment of battery technology. For example, patents relevant to the use of nickel metal hydride cells in cars were held by an offshoot of Chevron Corporation, a petroleum company. who maintained veto power over any sale or licensing of NIMH technology. 105. 106. Research, development and innovation. As of December 2019, billions of euro in research are planned to be invested around the world for improving batteries. 107. 108. Researchers have come up with some design considerations for contactless BEV chargers. Inductively coupled power transfer, ICPT, systems are made to transfer power efficiently from a primary source, charging station, to one or more secondary sources, BEVs, in a contactless way via magnetic coupling. 109. Europe has plans for heavy investment in electric vehicle battery development and production, and Indonesia also aims to produce electric vehicle batteries in 2023, inviting Chinese battery firm GEM and contemporary Amperex Technology Limited to invest in Indonesia. 110, 111, 112, 113, 114. 115, 116, 117, Ultra capacitors. Electric double-layer capacitors, or ultra capacitors, are used in some electric vehicles, such as Trinity's concept prototype, to store rapidly available energy with their high specific power, in order to keep batteries within safe resistive heating limits and extend battery life. 118, 119. Since commercially available ultra capacitors have a low specific energy, no production electric cars use ultra capacitors exclusively. In January 2020, Elon Musk, CEO of Tesla, stated that the advancements in Li-ion battery technology have made ultra capacitors unnecessary for electric vehicles. 120. Promotion in the United States. There are several kinds of policy measures to make BEVs more desirable. Purchase-based incentives include a tax rebate or a subsidy when buying or registering a modern BEV. Use-based policy measures include providing an exemption for congestion charging for BEV users, allowing BEV users to use bus lanes, or giving free parking to BEVs. These can be classified into local and global policy incentives. Local incentives including congestion charge exemptions or free BEV parking in a city only influence those located in this specific area. Global policy incentives including subsidies or national tax rebates apply only in a country. 121. In 2009, President Barack Obama announced 48 new advanced battery and electric drive projects that would receive $2.4 billion in funding under the American Recovery and Reinvestment Act. The government claimed that these projects would accelerate the development of U.S. manufacturing capacity for batteries and electric drive components as well as the deployment of electric drive vehicles, helping to establish American leadership in creating the next generation of advanced vehicles. 122. The announcement marked the single largest investment in advanced battery technology for hybrid and electric drive vehicles ever made. Industry officials expected that this $2.4 billion investment, coupled with another $2.4 billion in cost share from the award winners, would result directly in the creation tens of thousands of manufacturing jobs in the U.S. battery and auto industries. The awards cover $1.5 billion in grants to United States-based manufacturers to produce batteries and their components and to expand battery recycling capacity. U.S. Vice President Joe Biden announced in Detroit over $1 billion in grants to companies and universities based in Michigan. Reflecting the state's leadership in clean energy manufacturing, Michigan companies and institutions received the largest share of grant funding of any state. Two companies, A 123 Systems and Johnson Controls will receive a total of approximately $550 million to establish a manufacturing base in Festate for advanced batteries, and two others, Compact Power and Dow Kokum, 123, will receive a total of over $300 million for manufacturing battery cells and materials. Large automakers based in Michigan, including GM, Chrysler, and Ford, would receive a total of more than $400 million to manufacture batteries and electric drive components. Three educational institutions in Michigan: the University of Michigan, Wayne State University in Detroit, and Michigan Technological University in Houghton, in the Upper Peninsula, would receive a total of more than $10 million for education and workforce training programs to train researchers, technicians, and service providers, and to conduct consumer research to accelerate the transition towards advanced vehicles and batteries. U.S. Energy Secretary Stephen Chu visited Celgard 124 in Charlotte, North Carolina, to announce a $49 million grant for the company to expand its separator production capacity to serve the expected increased demand for lithium-ion batteries from manufacturing facilities in the United States. Celgard was planning to expand its manufacturing capacity in Charlotte, North Carolina, and nearby Concord, North Carolina, 125, and the company expected the new separator production to come online in 2010. Celgard expected that approximately hundreds of jobs could be created, with the first of those jobs beginning as early as fall 2009. EPA Administrator Lisa Jackson was in St. Petersburg, Florida, to announce a $95.5 million grant for Saft America, Inc., 127, to construct a new plant in Jacksonville, the site of the former Cecil Field military base, to manufacture lithium-ion cells, modules and battery packs for military, industrial, and agricultural vehicles. Deputy Secretary of the Department of Transportation John Porcari visited East Penn Manufacturing Co., 128, in Leon Station, Pennsylvania, to award the company a $32.5 million grant to increase production capacity for their valve-regulated lead-acid batteries and the Ultra battery, a lead-acid battery combined with a carbon supercapacitor, for micro and mild hybrid applications. 129. On the 2nd of May, 2022, President Biden announced the administration will begin a $3.16 billion plan to boost domestic manufacturing and recycling of batteries, in a larger effort to shift the country away from gas-powered cars to electric vehicles. The goal of the Biden administration is to have half of U.S. automobile production electric by 2030. 130. The Inflation Reduction Act, passed on the 16th of August, 2022, aimed to incentivize clean energy manufacturing with a $7,500 consumer tax credit for EVs with gas-filled batteries, and subsidies for EV plants. By October 2022, billions of dollars of investment had been announced for over 24 U.S. battery plants, leading some commentators to nickname the Midwest as the Battery Belt. 131. 132. Promotion in Norway. Norway has become a leading example of BEV promotion. The BEV market share is highest in the world in Norway. The main reason being the strong incentives for promoting purchase and ownership of BEVs. Norway has an incentive package for BEVs that often equate or even make a BEV cheaper to purchase than an internal combustion engine vehicle, ICEV. In addition to the purchase price incentives, there are also incentives that make BEVs more cost-efficient and convenient in daily use. Incentive policies have a clear success for increasing BEV sales in Norway, making it a great case to learn from for other countries wanting to head in the same direction. 133. See also. Examples. List of hybrid vehicles. List of production battery electric vehicles. List of electric vehicle battery manufacturers. Plug-in electric vehicle fire incidents. Related. Battery charging. Battery electric multiple unit. Battery locomotive. Charging station. Dual mode vehicle. Electric car energy efficiency. Fly free energy storage. List of battery types.